Hello and welcome in this tutorial in which we will process the setting up of an eNod4b. To start, connect the eNod to your PC, then start eNodView. Select the eNod configuration mode and connect your eNod. During our test, we will use a belt conveyor under which we have placed a load cell surmounted by a plate of 150 mm length, on which the belt rubs. As with other eNods, the first step is static calibration. If you need help with connecting and calibrating the eNod, please refer to the eNod connection and calibration tutorial. Once the calibration has been done, the filters must be adjusted. Here only the frequency 400 meters per second is available. I will use a low-pass filter of order 2 at a cutoff frequency of 1 Hz. I also add a 30 values average filter. If you need help to design filters, see the fast acquisition tutorial and the associated filtering tutorial. We will now click on the parameter button. We can now set up our system. The belt length, the conveyor angle, the number of revolutions required to make the zero or to learn the belt length or the speed sensor, and finally the automatic correction 0. On the right side of the window, you can adjust the speed sensor settings of your belt and the speed of your belt if it is fixed. The length of the weighing section. If you use a weighing idler, you can use the formula below. We will now launch the belt to see its empty behavior. If there is strong vibrations, a new adjustment of filters may be necessary. We will adjust the minimum weight of totalization. To do this, look at the belt load and set the minimum weight of totalization to make the load correspond. If your total is changing, your minimum weight is too low. Increase it until you have no longer evolution on totalization. We will now perform the dynamic weight calibration. To do this, we will put material on the belt and control the result. If the result is too large or too small, adjust the flow rate correction factor by dividing the actual weight by the calculated weight. Enter your correction coefficient Press Clear to reset totalization and repeat the comparison test. Here we get a difference of 2 grams for 2.5 kilos. At this moment our belt scale is set up. If we want to make a belt feeder, we now have to calibrate the flow rate. To do this, set the analog output to the function user-defined, save in EEPROM if necessary. Then go to Measure, click on Start and then activate the flow rate curves. Disable all curves except the average flow rate or the instantaneous flow rate. Enter a value in % of your analog output to pass materials on the belt. Wait for stabilization and note the associated flow rate. Repeat the procedure in several points according to the linearity of your process. Go back to Setup, then click on Flow Rate Calibration and enter the values you have found. Click on Send. When the calibration has been taken into account, the left dial turns green. Close the window. Switch to belt feeder. Set your analog output to flow rate control and save to EEPROM. Back in Parameters. Finally, assign the analog output to the material or the belt drive, as in my example. You can now assign a nominal flow rate to the process, set a batch dosing and alarms if necessary. Your belt feeder is now operational.